Okay, so today what we're going to do is we're going to continue our look at measurements of geometric shapes. And today what we're going to do is we're going to look at something called area. So remember last time we looked at perimeter, and perimeter means the distance what? Around on the outside, right? So for example, if you were building a fence, you would put that on the outside of your property, right? Around your property. Well, today what we're going to do is we're going to look at area, which of course you've seen before. Area means a measurement of the space inside a shape, right? Okay? So like for example, if we wanted to replace the carpet in here, we would measure that in area, not perimeter. Yeah? And there are formulas for area. Area is not like perimeter where you can just add up the sides, right? Instead, we're going to be looking for using formulas for them. So we're going to look at those, although you've seen them a million times. Our big concentration for this time, because remember, everything that we do is going to be building on your previous work, is we're going to be converting those area measures to different types of measures. So for instance, if it's given to you in square meters, we're going to change it into square centimeters. Okay? But you're going to see that because the metric system is such a nice, easy, predictive flow of information, it's very easy to convert them back and forth. Okay? So let's get started. Let's just go to the book and look at a few examples. All right, so just looking in your book, again, they define area as the amount of surface within the boundaries. So the area is a measurement of the space inside. So you might need to have that written down somewhere. Area is simply the measure of the space inside a shape. Okay? Now, that's a little bit of a cheat because we're talking about flat surfaces. Right? So we're not talking about like the air in the room. We're talking about the measurement of the floor or the measurement of the wall. So we're talking about the area of the space inside of a flat surface. So remember that there are different measures depending on the type of object or the type of space you're looking at. Okay? And we want to always remember, okay, that we include units in everything we do. Yes? And the units for area are always measured in what are called square units. And you can write that out in words, or you can use the mathematical symbol for square. What's the mathematical symbol for square, guys? Right, so an exponent of 2, yeah. So if we wanted square centimeters, it's centimeters with a 2 up there. Right? Because an exponent of 2 is called a square, and because it comes from geometry when we're measuring square units. So look at this one. This one's 1 millimeter squared, and that box is an actual representation of 1 square centimeter, that tiny little blue box they've got there, right? It's very tiny for millimeters. Okay? So square units. So whatever units you're measuring in, it's always square units. If you forget the square, then you can forget your answer because it's wrong. If you put millimeters instead of square millimeters, that is not correct at all, and it will be counted completely wrong. Okay? So you've got to pay close attention to your units as you do these. Okay? All right. Now, there are lots of different ways of finding the areas. If you're given a shape like the one we have here, where it's all measured in a bunch of squares, I could find the number of square units by simply counting up how many square units there are. Or, if you notice, there are 1, 2, 3, 4, 5 units across and 1, 2, 3 high, and we can just take those two things and multiply them together. Right? So we're going to talk a little bit about some basic shapes and how to find their units, and we're going to expand on this as we go. So let's just go back to paper really quickly. So remember, for the area of a square, you simply take the sides and square it. Area equals side square. Okay? Because you have two sides that are the same length, and so squaring them, and that's where that word square comes from. Right? For a rectangle, we do length times width. Now you will also see width described as height. It actually makes more sense to be height than width, but it doesn't make any difference. Same thing. So let me write that a little differently because that looks like it should be three things multiplied together. So width or height, whichever way you like to think of it. Some people visualize it a little better by thinking that rectangles have height instead of width. Okay? Makes no difference. And then we'll expand on that list as we go. But area typically has a formula attached where perimeters, most shapes don't have a formula for perimeter. You just add up the sides, right? Okay. Now, which means that when we do area for irregular shapes, we have to try to turn it into shapes we know. Okay? And we'll be working on those later. Right now, we're not going to concentrate too much on that. And we may add some more again in just a moment. We'll see what shapes they use. So, 1 square millimeter squared, is the area enclosed by a square with a side length of 1 millimeter, right? So you have 1 millimeter times another millimeter, which makes 1 millimeter square. And the reason you're getting those square units is because when you multiply 1 millimeter times 1 millimeter, 1 times 1 is 1, and millimeter times millimeter is millimeter squared. So what you're actually doing is you're multiplying units together, right? Now, that doesn't happen when you add them, because remember, when you're adding like units, you just get more of the same thing that you started with. So it doesn't square them there. So it's like saying 1 orange plus another orange, that makes 2 oranges, right? Okay? So the only reason that it's squared is if you're using what operation? Multiplication. So be careful. That's why perimeter is just in standard units, but area is always squared. Okay, keep that in mind as we go. All right, so think about the areas, a couple of areas, because again, we want to make sure that we're using things that make sense. If I was measuring the top of a desk, I might measure that in square what? Meters, maybe. It's still going to be a little smaller, but maybe square meters. Could I use centimeters? Yeah, but it'd be a pretty big number with the desk, wouldn't it? Okay. What if I was measuring the area of that calculator? Centimeters would probably be better. Right, yeah. What if I was measuring the area of the end of this pencil? Millimeters. What if I was measuring the area of the room? Meters. Definitely meters. What if I was to measure the area of New Zealand? Kilometers squared, right. Okay, so make sure you think about the types of measurement are still very much on our radar, yeah? Okay? Now, there are some pieces of information that are special. For example, a hectare is the area enclosed by a square with a side length of 100 meters. So in other words, it's a square and every side is 100 meters squared. Okay? You might want to know that. So let's write that down, guys. So 1 hectare, abbreviated HA, is a square whose sides are 100 meters. Can anybody then tell me how much area that would be then for a hectare?
10,000.
Okay, so meters, yeah. So meters squared. So you have 100 times 100, right? Yeah, you just multiply the sides together. Good. Okay, so it's just a special name for it because it's such a standardized unit. You've heard of hectares before, usually like property is measured in hectares, farms, etc. Okay? Okay, that's a completely different thing, and it doesn't convert very well because it's an English unit, it's an imperial unit. Okay, all right. So a square kilometer is the area enclosed by a square with the side of 1 kilometer squared, which makes sense, right? So 1 kilometer, 1 kilometer. So what we're going to do is we're going to look at finding some areas, and they're going to give us the area in lots of different spaces. For example, here they want us to find the area of the shaded area, and we're going to give our answer in square units. But because they've divided them into squares, in order to find out how many square units, what do I have to do if it's already divided into square units for us? All we're going to do is count them. So it doesn't matter that we have this odd shape like B. It's 1, 2, 3, 4, 5, 6 square units. Okay? Or you could say 6 units squared. Yeah, you can write it mathematically. I would be ecstatic if you did, right? But if you want to use words, you're more than welcome to. Okay? So do you see that? All right. We're still doing notes right now. Okay. Now, then the second thing you're going to be doing here is you're going to be talking about what area unit might be the best. So we're going to have a couple of those. But the real focus of this lesson is converting from one type of square unit to another type of square unit. So we need to think about what happens when you're looking at different types of units. So you can convert from one area unit to another. And that might be important. For example, say we need to add a bunch of things together. Well, in order to add them together, the units must agree. So I can't add square meters and square centimeters, right? I would need to convert them to the same units. Doesn't matter which one, but need to convert them to the same units before I could do the math with it, right? Make sense? Okay, so we're going to talk a little bit about how to do that. Okay, so if a meter squared is 1 meter times 1 meter, then if you want to convert that into centimeters, you just convert 1 meter into centimeters, and then the other meter into centimeters, and multiply it together. Okay? So you can look at it that way. All right? Now, again, here's the chart of the most common units, and notice they've included hectares on there. You're going to be using those. And you can either learn which things you need to multiply and which things you need to divide, or you can do that jumping thing. But hectares will not fit in there, so you'd have to just memorize that one. So to convert square units by jumping, right? You have in the middle you have your units. As you go this way, we have deci, then we have centi, then we have milli, right? If you go this way, you have deca, you have hecto, and you have kilo, right? Now remember, hectare is its own thing. It's 100 meters squared. So that one you just have to memorize. It doesn't fall in our chart because it's not really a measurement that's a metric measurement for length. It's a special category. It's a special thing. So just remember, you're just going to have to remember that one. Now, so if you're going to jump to the left, right, then even though the units are getting bigger, the number of units you have is getting smaller. So to the left, what we're going to do is we're always going to divide, right? The amount of things you have is getting smaller, even though the units are getting bigger. If you jump to the right, then the number of items you have is getting bigger, even though the units are smaller. So that's when you're going to multiply, right? And each jump is 10 because they're decimals. They're always that's the beauty of the metric system, why it works so nicely. Because think about it, in the imperial system, 12 inches is 1 foot, but the next unit is yards, and 1 yard is 3 feet. So there's no rhyme or reason for the conversions. But here in the metric system, it's always tens, right? So you always know your multipliers. But remember, we're talking square units. So square the number. Okay? Now, so all we're going to talk about is just going from one to another. So let's say I went from millimeters squared to kilometers squared. That would be a really big jump, but who cares? Okay? Now, to get from millimeters to kilometers, which direction am I going? I'm going to the left, your other right. Right? Okay. So that means if I'm jumping left, I'm going to be dividing. Okay? And now I need to see what number. Now again, this is going to be ridiculously big because you'd never do this. I'm going to 1, 2, 3, 4, 5, 6 places. So that's a 1 with 6 zeros. It's because it's 10, 100, etc. So, and of course we'd have to square it. Right? It's ridiculous. You'd never take millimeters squared to kilometers squared, right? I'm just showing you that it wouldn't matter. It still works, right? So that gives you the number you're doing. So if you're going left, you're going to divide, and each jump is a 10, right? Which means each jump is a 0, 1 with a 0, right? Okay? Now again, that one doesn't make any sense, but you could do it. Okay? Now, what if I'll do one of the others. Shh, ladies. Okay, now, what if I was going from meters to centimeters? Which direction? So that's starting in the middle, right? Going to the right. So that means I'm going to get more of stuff, right? So that's going to be multiply. And how many jumps did I make? 2, right? 2 jumps. It's three different units in it, but 3. So that's 2 zeros, but it's got to again be squared, right? So make sure you square it because we're measuring in square units. So you have to square. So you have to have, right? Make sense? So this kind of gives you instead of just memorizing a bunch of multipliers or dividers, you have a process for working with it as long as you remember to square it when it's square units. We did the same thing, but when we did it with perimeter, it wasn't square units, right? Okay. Now remember that these are your multipliers. So it doesn't tell you the answer. It just tells you what number you have to multiply times your original number to get to the answer. Right? So let's give it a try with a couple of these and see if we can convert back and forth. You seeing it? It's really easy. It's really easy, but you just practice it. Okay? All right. So let's go to the book. Yeah. Let's go to the book and practice. So here we go. So here, let's just do number 8. Guys, come on. All right. So number 8, we have 15,600 meters squared, and we want to take it to. That's a hectares one. Doggone it. Let's not do that one yet. Let's worry about that one. That's a spit. We will work with that. So I said H. Oh well, I started H too, didn't I? Okay, never mind. I swear, sometimes I worry about me. Centimeters squared to meters squared. So we're working in square units, yes? But it's still converting back and forth to units. Right? Okay. So we have, if we're working with meters, hold on just one second. Decimeters, centimeters, millimeters. Over here we have deca, hecto, and kilo. So I'm going from centimeters, that's here, to meters. So that means I'm jumping 2 places to the what? Left. 2 places left. So that means if we're moving left, are we multiplying or dividing? So dividing, and 2 places means 100 to the second power. 2 zeros. Right? So, exactly. Each jump gets a 0. Exactly. Yeah. Okay? So that means 100 squared. So we're just going to divide it by 100 squared. Now you can go ahead and work out 100 squared and then divide by that. Or you can just put it in your calculator. You're going to have calculators. Just put in 15600 divided by 100 squared. And it'll give you, there's a key. Hold on, we'll find it. Wait. So anytime you square something that's just a bunch of zeros, it's just going to double the number of zeros you get. So if you square 100, you get, instead of 2 zeros, you get 4 zeros. And the number of zeros, when you're dividing by that, the number of zeros just means how many places you're going to move the decimal. Isn't that what we did before? So we're moving the decimal 1, 2, 3, 4 places, which gives us 1.56 meters squared. So now that we know the mechanics of it, think of it like this. If we went from centimeters to meters. So think about it like this, because I'm trying to show you the jumping without doing any math. Okay? And you can. Watch. We went from centimeters to millimeters, which is a jump of how many decimal places? 2 decimal places. If it was perimeter, it would be 2 decimal places to the left. But we're doing area, which is squared. So 2 squared means not 2 decimal places to the left, but 4. So in other words, you don't have to do any math at all to convert these. All you have to do is move the decimal. But since we're talking about square units, it's not going to move 2 places. It's going to move 4. Do you see that? So, 50,600 centimeters squared to meters squared to centimeters for meters, that's 2 places to the left. But because I'm doing square, I won't move it 2 places to the left, but what? 4. But 4 places to the left. And there's my answer. So again, all you have to do is move the decimal. Okay? Now, all right, so, but you remember, we're squaring them. So if I move the decimal 3 places, what am I really going to move it? Squared means 9.
Oh, gee.
No, sorry, not going to work. No? Yeah, we're going to double it. Watch. There you go. So all you need to do is double the number of places. Right? So move it left, but twice as many places as you'd move it before. Move it right, but twice as many places that you moved it before. It's good? So let's look at the homework and see if we can do another one of these. Now, all right, I don't want you to do any math here. Just want to do this. So look at O. So we have 0.0092 meters squared, and I want to take that to millimeters. So if it's meters, decimeters, centimeters, millimeters, how many jumps is that? 3 jumps to the what? But we're squaring it, so we're not going to take 3 jumps. We're going to take 6, twice as many. So 1, 2, 3, 4, 5, 6. Okay? Which gives us 0092 with 2 zeros added. So there's my new decimal. So do I need these decimals in front? Nope. So all we're doing again is just moving the decimal. But because we're squaring, we're going to move it twice as many times as our jumps tell us. We went to the right. So we moved it to the right. Yeah? So we went to the right, so that means our decimal moved to the right.
But then should there be a blank?
Well, it's at the end, so do you need to write it?
Oh, do you only do this with
You always do it, no matter what. Just like last time.
What about that number?
This is no different, we're just moving, this is no different than what we did before. It's just, let's look at another one. Hold on, guys. You're making this a lot harder than it has to be. So look at 3.6 meters squared to centimeters squared. We have meters, decimeters, centimeters, right? So we're moving from meters to centimeters. That's a jump. That's how many jumps? 2 jumps, yeah? But we're squaring it, so that means we need to double them. So we're really going to move how many jumps? 4. So here's my decimal. It's going to move 4 places to the right. So 1, 2, 3, which means that I have 2 spaces that don't have any values in them. So what do I have to add? Zeros. So 3,600 centimeters squared. Pardon me? Oh, I only moved 3. I'm sorry. I can't count.
Do we have to say squared at the end?
Absolutely. Yes, your units have to be squared because it's an area unit. So you have 2 met things. You can use your calculator and multiply, or you can just move the decimal. Okay? How nice is your life now? Okay, so you're going to be doing those. All right? Yeah. Now, when you're doing these hectares, just multiply or divide. Because, okay. Right. Because you know that 1 hectare is how many meters?
100. 10,000.
Well, it's 100 on a side, so it's 100 squared.
10,000.
Right? So you can just do the conversion by multiply or divide. Okay? Right. Okay. So let's do your homework. You're going to do exercise 11C1 and 11C2. 11C1 is just those areas, and there's only a couple of them, but 11C2 has the conversions. Pay particular attention to these at the bottom where you have it in words, because remember, on a test, you're not going to have many where you're just going to have to convert. You're going to mostly have to convert using words.